Welcome. Today we'll review the Avaya Contact Recorder 12.1 release. This version of ACR contains many new features, an updated technology stack, new integrations, and scalability improvements. While anyone who needs to understand more about the latest in Avaya workforce optimization will benefit from this overview, this session is aimed at those who already understand the basics of Avaya Contact Recorder. Thanks for making time in your schedule to learn about these enhancements, and with that, let's get started. As the name suggests, 12.1 is an ACR-specific release. It's important to note that ACR 12.1 will offer compatibility with Avaya WFO R12 applications only. Avaya QM 12.0 will require some minor software patches to enable QM live monitoring functionality, which we'll discuss later. With this exception, no other Avaya WFO R12 software will change in this release, and all other applications will retain the R12.0 version number. As with previous releases, please ensure you use the latest version of the Avaya WFO server sizing tool to support this new version of ACR. With so many enhancements in the new release of ACR, it's easiest to communicate these improvements to customers in terms of common themes. Listed here, these themes provide both new and existing customers a simple way to understand the benefits of implementing or upgrading to Avaya Contact Recorder 12.1. These are generally grouped into feature function enhancements, technical stack and technology updates, security, and total cost of ownership improvements. In this presentation, we'll review the majority of the enhancements listed here and their related themes. More detail on configuration and administration options will be available in the ACR 12.1 Planning, Installation, and Administration Guide. Let's start with an overview of the new enhanced application functionality in this release. This 12.1 theme will be of most interest to users of the ACR or QM search and replay interfaces. New session-based visualization is an ACR search and replay enhancement. It makes it much simpler to identify and work with complex multi-segment contact recordings. Content recorded by ACR can still be searched for based on individual segments, as with previous releases, but with 12.1, contact searches can be based on an overall recording session. ACR session searches show all relevant portions of an overall contact recording, including consults, conferences, multiple parties on a call, holds, and transfers. Calls containing multiple segments can now be replayed as an entire session without the need to select individual segments in sequence. In the simple call scenario shown here, the top two lines in the replay interface represent the calling party and the agent who spoke with the customer. Audio activity is shown in green. As in previous versions, ACR's Layout Builder feature allows users to select what search filters are available to users and control what contact recording attributes are displayed in search results. In another simple scenario with a hold and retrieve, note that holds or any portion of the contact with silence are represented with orange bars, while audio activity is represented by green. ACR deployments which support stereo recording will show separate audio energy for calling and called parties. Here we're looking at a blind transfer scenario with three parties represented on the call, all shown in the session view. Take a look at the highlighted area in the search results under the Matching Sessions column. Notice that the graphic circled in red shows the same information as the session view at the top, but in a condensed format. The idea is that ACR users will quickly be able to identify complex or problematic recordings with multiple parties, conferences, or transfers. Users can see this information in the search results without selecting a contact recording. example of a more complex scenario in which a second agent is brought into a consultation with the first agent and the customer. The second agent drops from the contact and the first two parties continue. Notice that providing the ACR user with a visual representation of multi-segment, multi-party calls, Session View is a particularly helpful enhancement. When implemented with ACR 12.1, Quality Monitoring R12 now offers real-time agent monitoring capabilities. Users with appropriate security profiles can live monitor voice and agent screen capture. We'll take a look at these interfaces in a moment, but note that there are two ways to access live monitoring functionality through Avaya QM. Contact center supervisors or quality assurance personnel will typically use the QM supervisor dashboard to launch live monitoring. This interface offers evaluation functionality for users who participate in agent quality assessments. Those users who may have occasional need to live monitor agents, but typically don't need to evaluate agent performance, may use the Contact Monitor user interface. Note that when initiating a live monitor session via QM, contact recording will be launched if that agent is not already being recorded. If PCI recording pause and resume is deployed, live monitoring sessions will not mask PCI-sensitive data. Recordings stored by ACR and subsequently played back with ACR or QM will have appropriate audio and screen masking. For this and other reasons, if a customer desires, access to QM live monitoring can be disabled. Here we see the supervisor dashboard interface for live monitoring through Avaya QM. The live monitor interface allows users to select the QM group, see the agent's real-time status, and, if they're currently on a call, the elapsed time for the current call. The user also has access to the Evaluate feature shown in the upper right, which allows the user to complete an evaluation form during the live monitor session. And, as mentioned before, users can also use the Monitor function to access live monitoring. The right half of the screen shows the live monitoring interface, which plays live audio, shows the agent workstation screen capture, and shows relevant data about the current call segment. While not new to the 12.1 release, support for live monitoring is still available for Avaya Contact Recorder customers. Enabling ACR's live monitoring feature does require a free-of-charge license key. Users can be granted or denied the ability to live monitor, similar to Avaya Quality Monitoring. Unlike Avaya QM's live monitor feature, ACR does mask PCI-sensitive voice and screen data during live observation sessions. New to ACR 12.1 is the ability to route live monitoring requests through a central replay server. This makes it simpler for users to leverage live monitoring in environments with multiple ACRs. ACR live monitoring is supported for any customer using Recorder Release 11 or higher. The recorder must be licensed for live monitoring and patched to the most recent service pack. It's a common requirement of contact center quality management programs to evaluate agent use of after-call wrap-up time. The QM after-call work timer is an attribute of QM recording rules, which enable agent workstation screen capture to continue for a period of time set in seconds after the call. This attribute can be set on a per-rule basis in Avaya QM. And as a reminder, this functionality is included standard in Quality Monitoring Release 12. Here we're looking at the after-call work attribute of QM recording rules. It's easy to set up. Remember that any one customer contact may satisfy multiple QM recording rules. If that situation occurs, the QM recording rule with the longest after-call work timer will be enforced. Most customers choose to automate enhanced recording tasks such as call tagging or pause and resume for PCI compliance via desktop and process analytics. However, an alternative method to accomplish these tasks is via Agent-Initiated Monitoring, or AIM for short. AIM is a standard component of the contact recording, QM, and WFO packages. It allows agents to manually control call tagging and recorder control through a Windows tray-mounted icon. AIM now works in both ACR or QM deployments, although most commonly with quality monitoring. AIM software is installed as part of the agent's screen capture installation routine. Note that use of agent-initiated monitoring does not require the customer to be licensed for screen capture. Finally, the contact recording desktop client for CS1000 environments has been discontinued as of ACR release 12.1. Agent-initiated monitoring is supported for all environments. On the right of this slide, we see the options presented to the agent through agent-initiated monitoring. The options available to agents are configurable during the installation or via Windows registry settings. That is, administrators can give the agents the ability to annotate recordings, but not necessarily the ability to block recordings. To use AIM with ACR, all bulk or 100% recording targets must be configured as free seating. ACR supports a range of desktop and process analytics triggers. Customers requiring custom call tagging from a desktop application, PCI pause and resume, or start and stop commands can deploy DPA's Advanced Desktop Analytics package to accomplish these tasks and much more. Note that start, stop, or pause resume triggers can be implemented for voice recording, screen capture, or both. Also note that DPA requires an agent to be on an active customer contact for voice and screen recording start commands to be initiated. As in previous releases, implementing DPA requires associated licensing as well as WFO framework support. Many ACR customers require the ability to export contact recordings to third parties. In the next few slides, we'll review both existing and new options to accommodate these requirements. The standard export feature, currently available in ACR 12.0, provides ACR users multiple options. Users can select one or multiple recording segments and export recorded audio into a format which is playable using most third-party media players. A CSV or HTML file can also be exported, which contains details about the selected calls. Both can be exported to a single zip file, which will contain individual WAV files and relevant call details. New to Release 12.1 is the ACR Advanced Export feature. Users can now select one or multiple recordings through the Search and Replay interface and export both voice and screen recordings. Using this option, recordings are exported as a single Avaya Advanced Replay, or AAR file, containing both recordings and details. AAR files are designed to be used with the new offline ACR player application. Even better, when using the Advanced Export option, multi-segment calls can be played back in a single session. Here we're looking at a screenshot showing the basics of how to use the Advanced Export feature. Users can select one or multiple files and specify the export location of the resulting AAR file. A progress indicator displays how many recordings have been processed and provides a download link for the ACR offline player. Some customers, particularly outsourcers, require all audio recordings to be exported for use by third parties. To meet this requirement, ACR 12.1 has an optional, licensable capability to export call audio. Note that this feature is an at-cost option requiring a platform license and professional services to install and configure. ACR Mass Export can be configured to export all audio recording segments or selective recordings based on campaigns. Recordings are forwarded in near real time from ACRs associated with a central replay server running the mass export routine. Recording files are forwarded from the central replay server to NAS, SAN, or network disk provided by the customer. ACR recordings are forwarded to that destination in G.729 format. It is important to note that once mass export of ACR voice recordings is accomplished, no search, replay, or deletion mechanism is provided. Customers are expected to manage this process. Professional services can configure ACR mass export to support a folder hierarchy based on customer specifications. In the example shown here, audio is exported to a folder based on the calendar year and month they were recorded, as well as subfolders for days and skills. Mass export can also be configured to forward audio recordings in a customer-specified naming convention. This will facilitate identification of exported call audio. Again, the ACR mass export feature requires a 4-fee platform license and associated professional services to configure the export routine to meet customer specifications. It is not included standard with ACR Release 12.1. ACR 12.1 now includes a fingerprint validation utility. The fingerprint validator can be used to determine if a recording has been tampered with after it was recording. The utility is a text-based console application, and both single and multiple recordings can be validated. Note that use of this feature requires that fingerprinting be enabled on ACR 12.1. It currently does not check archived media, so archived recordings need to be copied from their archive destination to a workstation to be validated. Listed here are the new server specifications for an ACR 12.1 recorder. The CPU and RAM requirements have increased over previous releases, so let's take a look at the impact this has on system sizing and scaling capabilities. Shown here are the new total channel capacities for ACR 12.1. The channel capacities vary depending on the type of voice recording method or switch type. Most importantly, screen capture sessions are no longer a sizing factor in ACR capacity. So, for example, if using DMCC to record in a communication manager environment, ACR 12.1 can support a maximum of 1,200 voice and screen capture sessions. For customers upgrading from ACR 12.0, the legacy hardware specifications will still be supported for previously published channel capacities, but customers who require the increased channel capacity of 12.1 will require the new minimum server specifications. Note that virtualization of ACR, average handle time of less than 1 minute, and constant 24-hour call volume still affect ACR capacity. As in the past, the Avaya WFO server sizing tool will calculate the number of required recorders based on customer business requirements. ACR 12.1 now supports updated operating systems, including Red Hat Enterprise Linux 7 and Windows Server 2012. Windows Server 2008 and some older versions of Linux are still supported. Please refer to the ACR 12.1 Planning, Implementation, and Administration Guide for additional details. Linux is only required for Communication Manager implementations using passive IP recording. Browser support in Windows 7 environments now includes Internet Explorer versions 9 through 11. Windows 8 or 8.1 environments support IE 10 and 11. Also added is support for newer versions of server-side Java and Tomcat. ACR 12.1 provides scripts to update these components. Previous releases of ACR leveraged ActiveX controls for contact replay. ACR 12.1 replaces the ActiveX requirement with Java, or JRE, which is now required for users of the ACR Search and Replay user interface, live monitor, and export functions. The move to a JRE-based client supports a more powerful user interface and brings ACR in line with other WFO technologies. resource for checking core platform support for ACR and other WFO modules is the Avaya WFO Interoperability and Compatibility Guide. This Excel document is available on the Avaya Sales and Partner Portal and contains the latest integration and platform support options for Avaya WFO. Listed here are the minimum requirements for ACR in CM, CS1000, and AACC environments. Previous releases of Avaya Contact Recorder required an ACR master per switch instance. That is, if a customer had 3 independent instances of Communication Manager, we would require 3 ACR master recorders. ACR 12.1 now features support for multiple switches. A single master ACR can now communicate with multiple switches, or, using ACR terminology, multiple data sources. Any combination of CM, CS1000, AACC, and dialer instances can be supported by an ACR master. This provides clients the benefits of centralized license key management, administration, archival, and search and replay. Note that multi-data source deployments does not necessarily remove the requirement to have instances of ACR standby or slave recorders installed at remote sites. Most deployments will still require at least 1 recorder per contact center to localize the audio recording function and associated RTP. Currently, ACR 12.1 supports up to 16 data sources per master ACR. If your implementation requires more than that, please contact Avaya Product Management for review and approval. Shown here under the General Setup tab, multiple data sources can now be configured on a master ACR. In this example, note that Avaya dialers are considered a data source, along with CM, AACC, and CS1000s. In multi-switch deployments, ACR can accommodate conflicting dial plans by adding a character or numerical switch identifier prefix to the data source configuration. This allows, for example, an extension of the same number to exist on multiple switches and still be supported by a single ACR master. This optional setting is configured in the ACR properties file. New to ACR 12.1 is support for AMS zones in AACC deployments. This allows ACR administrators to configure a recorder or pool of recorders to work with a specific Avaya media server zone to minimize WAN traffic. Here are a few examples of ACR property file settings which map ACR recorder pools to AMS zones. Use the AMS zone name followed by the associated ACR pool name to ensure recording takes place at a specified location. ACR 12.1 now supports designated screen recorders. This architecture is particularly useful in environments with centralized voice trunking and distributed remote contact centers requiring agent workstation screen capture. In these configurations, screen recording can be forced to use a local ACR or ACR recording pool as the preferred destination. ACR will record screen capture locally to the remote contact center. Voice and screen are synchronized at the time of playback request through either Avaya QM or ACR Search and Replay. The ability to encrypt agent screen capture between the agent workstation and the recorder has been added to the 12.1 release. Note this configuration option only covers encrypting screen capture in transit and does not provide the at-rest file encryption provided by the ACR recording encryption option. Deploying screen capture encryption will require certificates to be deployed on agent workstations, ACR, as well as users who require playback of screen capture sessions. Dual monitor screen capture configurations are also supported. support for dual monitors is generally limited to the use of a single video card with 2 monitors using the Windows Extended Display feature. For ACR implementations using passive IP recording, sometimes referred to as port mirroring or VoIP intercept, several notable improvements in recorder performance have been added. Most notably is the ability of ACR to persist target phone IP addresses after a recorder restart. The benefit here is that only IP phones which have changed their addresses during that period will be affected. ACR also supports use of alternative recording methods in the event of issues related to passive IP configurations. The first is the ability to utilize DMCC or TDM recording ports for any scenario in which the IP address of a phone connected to a call is unknown. The second scenario covers situations in which ACR has a valid phone IP address, but no RTP is made available to the recorder. ACR 12.1 introduces support for recording audio using the SIPREC protocol. SIPREC support will be provided for ASBCE and Oracle Acme Packet Session Border Controllers in Communication Manager environments. As with all voice recording methods, use of SIPREC has advantages and disadvantages. The advantages of SIPREC include simplified network design, primarily because unlike passive IP recording, SIPREC does not rely on sniffing span or mirror ports. Also, in large deployments, the overall number of DSP resources required by DMCC is reduced. The disadvantages of SIPREC include the inability to record internal calls, limited call information made available by the SBC makes CTI a prerequisite, and additional licensing and capacity planning requirements on the SBC. The SIPREC protocol describes a method of active voice recording using a supported session border controller. The SIPREC standard uses the term SRC, or Session Recording Client, to define the SBC functionality responsible for forwarding RTP and SIP metadata to the SRS, or Session Recording Server. In our case, the SRS is the SIPREC data source defined on the Avaya contact recorder. In practical terms, the following items must be noted for any ACR design requiring SIPREC. SIPREC recording is limited to Communication Manager defined extensions or endpoints. AES with both TSAPI and DMCC services must be provided in all SIPREC deployments. TSAPI messaging provides the required metadata required to search and replay any recording made by SIPREC. DMCC is required to record any internal calls or call paths that do not traverse the SBC. This diagram illustrates an ACR 12.1 recorder receiving RTP from both an SBC via SIPREC and from Avaya media gateways via DMCC. SIPREC RTP streams can be sent to ACR in either G711 or G729 stereo audio codecs. Now let's review some of the service and supportability enhancements included in the upcoming release of Avaya Contact Recorder. The new Server Status Administrative page will show the current status and viability of all associated ACRs. This status is available on central replay servers, ACR masters, or ACR standby recorders. If an ACR cannot be reached in 2.5 minutes, a visual alert will be raised on the server status page. This threshold is configurable. Similarly, if the oldest recording on an associated ACR exceeds a configurable threshold, alarms can be raised. This alarm setting is designed to alert customers to recorder issues due to unknown error conditions or configuration problems. The new ACR usage report shows the number of recordings generated for each recording target and the number of distinct calls observed on that recorder, the maximum number of telephone replay ports, if any, configured at any time during the reporting period. Configuration records are retained for 3 months by default. Each night after that period has elapsed, a background job deletes any records older than this. This report is accessible via URL. Once the report is successfully displayed, a copy of the report is written to the ACR log directory and can be viewed with any text viewer. New report requests will overwrite the previous log. ACR can now log changes made to bulk, on-demand, and meeting recording modes if the new configuration reporting feature is turned on for the recorder. The log will show both the current configuration of all recording targets and will note additions to and deletions from the recording mode. An example of the text report generated is shown here. The configuration report will help ACR administrators audit and protect against lost recordings due to system configuration changes and recording target deletions. Finally, ACR user accounts only need to be administered on the designated ACR master or primary central replay server. User account information is now automatically copied to other servers. For convenience, only admin and restricted admin accounts are copied from masters to slaves. User accounts are not commonly needed on slave resource recorders. And that concludes our review of Avaya Contact Recorder 12.1. As always, thanks for your time and attention. Happy selling, and good luck.